Hi everybody, this is Mrs. Raposa. I'm making this video for two reasons. Number one, we didn't finish the last example in class, and that might help you to do some of the homework problems. And number two, there were a couple of mistakes in the notes that we took in class. I just want to make sure we have those fixed up. So the notes we took today, Monday, November 8th, on section 2.6, rational zero theorem, we said that if a polynomial function p of x, nth degree, whatever n is, maybe it's a fifth degree, fourth degree function, if it has rational roots, those rational roots can be written as p over q, where p is a factor of the constant term, not the leading coefficient. It's a factor of the constant term. So the numerator will be a factor of the constant term, and q, the denominator, will be a factor of the leading coefficient, a sub n. We already did example one together in class. So let's take a look at the next example. We had to first list the possible rational roots of this polynomial function, this fourth degree function. So we looked for the factors of p, the constant term, and the factors of -4 or positive -1, positive -2, and positive -4. Then we have to list all the factors of q, the leading coefficient, 3. And the factors of 3 are positive and -1 and positive and -3. I think in class I mistakenly was thinking the leading coefficient was 2, or maybe someone said that and we put it in there. But anyway, I noticed later that the notes had 2 here, and it should be the factors of the leading coefficient 3. So positive and -1, positive -3. So these are our possible rational roots or possible zeros of this equation. It could be any one of these numbers divided by any one of these numbers. So let's look for the combinations. 1 over 1, positive or negative. I think I forgot the positive or negative sign here. Or positive -2 over 1, or positive -4 over 1. Now let's take each one of these and put them over 3. So positive -1 over 3, positive or -2 over 3, or positive or -4 over 3. So those are the possible rational roots. We used our graphing calculator to graph this function to see where it touched or crossed the x-axis. I can't use a graphing calculator on my computer screen, but I can go to Desmos. So I went ahead and put that equation, that fourth degree function, into Desmos. And this is what I have. We could see that it touched the x-axis, looks like at -2. Desmos, it's really easy. You can just see where the zeros are. But we've decided to find out what polynomial we would get if we factor out x plus 2. Because if the zero of the function is -2, then one of the factors of the function is going to be x plus 2. So we're going to rewrite this fourth degree function as x plus 2 times a cubic. And we did that in class. So we divided this fourth degree function by x plus 2 using synthetic division. And we ended up with this fourth degree equation is equal to x plus 2 times 3x cubed plus 7x squared plus x minus 2. Now what we want to do is, let's see if we can break this down some more. Find a factor of this. Maybe this can be factored and has another linear factor. So to do that, you can go to your graphing calculator and type in y equals 3x cubed plus 7x squared plus x minus 2. You can stop the video and go ahead and put that into y equals. I've gone ahead and put it into Desmos, the cubic function, to see what the zeros of that function are. And I could see that -2 is a zero of this equation too. So the other two zeros, they don't look like they're rational. So, but we'll find out what those are in a second. But anyway, we can break this down into x plus 2 times x plus 2 times a second degree equation. So let's go ahead and use synthetic division to divide this cubic function by x plus 2. So I set up the coefficients 3, 7, 1, and -2 here, and put -2 outside because I'm going to make this as x plus 2 times x plus 2 times some second degree function that will give me this fourth degree function. So we're factoring a little further. So using synthetic division, I start with the leading coefficient 3. 3 times negative 2 is negative 6. Add 7 and negative 6 to get positive 1. Then do 1 times negative 2 to get negative 2. 1 plus negative 2 is negative 1. And then negative 1 times negative 2, which is positive 2, add them, and you get a remainder of 0. So these are the coefficients of my second degree polynomial. So what I've done is I've rewritten this fourth degree polynomial function as x plus 2 times x plus 2 times this factor, 3x squared plus x minus 1. So now let's find the zeros by setting each factor equal to 0. So what we're doing here is I've set the first factor, x plus 2 equal to 0, which gives me x equals negative 2. And again, I have negative 2 as a double root when I set this factor equal to 0. Let's go ahead and set this quadratic equation equal to 0 to find the other two roots. The other two roots are going to be irrational. I know that because when I compute the discriminant, b squared minus 4ac, I get 1 minus 4 times 3 times negative 1, which is 1 minus negative 12, or 1 plus 12, which is 13. And so the number that goes under the radical sign is not a perfect square, which means I'm going to have irrational roots for the last two roots. So let's go ahead and find out what those two irrational roots are. So we know that a is 3, b is 1, and c is negative 1. And when you throw those into the quadratic formula, negative b becomes negative 1 plus or minus the square root. We already computed this. This is 13. All divided by 2a, and that'll be 2 times 3, which is 6. So the last two roots are going to be irrational. Negative 1 plus the square root of 13, all divided by 6. And then negative 1 minus the square root of 13 divided by 6.